Okay, check 1, 2. I'm testing my audio to see if you can hear me. Let me know in the chat. I realize the balance might be a little bit off with the music, but I won't be playing music while I'm speaking otherwise, so hopefully it sounds good to you. Okay, be live in about a little over a minute or two. I guess I am live now, but properly starting in a minute or two. Oh. This is gonna be a little rough today. Okay, but I can do it. Okay, see you soon. Yes, James, you are hearing me correctly. I think I have a cold. I was wondering if anybody would notice. So much for my starting date of September 15th, but I'm starting anyway. Hi. I guess my timer needs to be adjusted if I'm going to play 2 songs before I start. Should also let everybody know before I begin there's a bee flying around this room. It seems to be mostly attracted to the brighter lights, so I don't think it will come and sting me. Hopefully I'm not muted. No, you can hear me. I'm checking out the chat here. Oh, new comments. I haven't been reading the chat. Okay. Hi everybody! It's Monday, September 15th. I don't know. I feel like things are a little rough for me these days. I mean, they really aren't in the grand scheme of things. I'm doing quite well. You should not be worrying about me. But I suppose if you want to indulge an old man who's been on YouTube for a decade in his own woes and angst, I mean, I'm really trying to figure out a way to get this coding train back onto the tracks in the way that it once was. But maybe that will just never happen, and it will just be what it will be, which is what it is. Hi, everybody. Where are you watching from? I love to hear that in the chat. DJ Mangus says, oh, I don't even have to, I forgot that I have this way of doing this, which is DJ Mangus says, morning, Dan. Nice to see you live. First time in a while I've been able to attend. Thrilling. Well, thank you for being here. I'm also going to add this comment, which is audio is good. You got a cold? I think so. I only started to feel it this morning. Could be allergies, but my head is cloudy. I'm a bit congested. I have a bit of a headache. My mind is not operating on full capacity, so bear with me. And what I was saying, and I think this button here will take the comment off the screen, and I can click over here and kind of keep an eye on the chat. Chairless crocodile watching from Greece. Where in Greece? I have many connections to Greece, and I was there over the summer. Many connections. I have like one connection, but and so Germany and Italy and Turkey, incredible. India, I love to see people from all over the world. Okay, let's have a little powwow for a second, because I do not want to. Well, what is wasting time, if anything? I don't know, but I don't want to use up a lot of time with my banter. I want to get into building a project on today's live stream. But if you will first indulge me, so, and let me do a little experiment here with using this vibe board for a second, just to try to. Where did I put the? I mean, you can't see me right now, but I have no idea where I put the marker for this thing. It's not a marker. It's like a. Here it is. Okay. No, don't look at me. Don't look at me typing in my code. Okay, hold on. Come back over here. This thing goes to sleep after like 1 minute. I've got to find that setting. Okay. All right. Somebody put. Oh, I need like one new feature I want on my live stream is I want to be able to press a button. I want to be able to type in. Oh, this is easy. I could build a web app to do this for me. But essentially, I want to be able to put in a timer and press a button and have a big sound effect go off when it's over. Because right now, no more than maybe, let's say 7 minutes. 10:45. Oh, I'm talking to the wrong camera. 10:45. I don't want to be talking about my plans anymore. Okay. This camera is weird, but maybe it's fine. I'm doing my best. Deep breath, everybody. Okay. If you tuned into any of my live streams over the summer, first of all, if you didn't and you like want to go watch them, I mean, that's wonderful because my channel views are very down. It's fine. No, it's fine. But I did 3 live streams. 1, I just talked for a while about like, I'm trying to get back into the coding train. 2, I had Kit from P5JS talking about P5 2.0. 3, I had Dr. Christian Hubicki. And by the way, I should say Dr. Kit Kuksinak. I mean, I don't know why sometimes I use the doctor title for people and sometimes I don't. Anyway, I had these wonderful guests. They're both doctors. But Christian came on and talked about robot controllers. And we have grand plans to do many more streams and video topics together. I don't know how I'm going to find the time to do that. But I have a goal for this fall that I have to complete. And honestly, it was kind of a goal for the summer that I didn't even, at least to get started. But I want to remake all my P5 beginner videos. And I might try to start that today, but here's the problem. I have like this challenge for myself, which is that, okay, well, let me put it this way. There's a kind of video topic that I'm very comfortable doing, which is just teaching a concept in programming and implementing it and kind of talking spontaneously about it. I feel this, I don't know, obligation, I feel this importance, but maybe I really shouldn't. I should just toss it to the side to, at the beginner of these videos, at the beginning of this video series, which is all like little mini tutorials in P5, to give you some background. What is creative coding and its history up until P5? So I've been working on some slides to cover this in a sort of short, hopefully 10 or 15 minute way, but they're not done. So I feel like, can I really do the, I just pulled a muscle in my neck, I think. And I know the lighting is kind of off. I don't know. It's not terrible. But one thing that's good here, just to show, I want to make sure this is working, is if I come over here, no, come on. Why is this not working? Shoot. Okay, I'm back here. People are talking about the YouTube views being down. That's not really my problem. I understand. We could go off on a tangent. I've been following a lot of people talking about views being down, but my issue, my views are down because I'm not making any videos. But anyway, okay, let me back. We have an issue, though, that's going to have to be fixed. I'm going to finish it. I only have 3 more minutes. Okay, so I want to do this. The other thing is there's this whole thing where there's all this AI stuff, and I feel like I need to talk about that and have a point of view around it in order. And I mean, that's relevant to everything across my channel. So I actually was hoping today to spend my live stream covering a lot of this stuff, but didn't really finish these slides. Got this cold now. The setup is still, I'm kind of getting used to it, even though it's the same setup I'm using for a while, but some new stuff here. So I think, we'll see. This is not what I'm going to start with today, but I wanted to talk about this. First of all, if anybody is interested in helping with these slides, join the Coding Train Discord and give me a tag at thecodingtrain.com/discord. Press a button. The URL comes up on the screen. It's not happening because I don't have that feature right now, but that would be welcome. Okay, put this over to the side. I think that's actually, so, all right, I need to fix an issue. So please, it was working earlier this morning when I was getting everything set up, and now I don't know if it's like a simple issue or a complicated one. So please bear with me for a second. Something very important here is I am hoping the point of doing this is all sorts of interesting questions in the chat here. Come on, people. Okay. All right. Let me see what's going on. I need to, the camera source is correct. Okay, I think there's a small issue. If you will, I'm just going to work. I'm going to try. What I'm trying to do is make sure I am recording the direct feed of what I'm drawing on the whiteboard to disk. So let me come up here and just check something. Okay. Oh, nope. Okay, so that's that. And that's not, okay. I'm going to, I don't know how to fix this. There's a few things I need to figure out here. I'm sorry, everybody. Let me just put on some music for you. One moment, please. All the sources are correct. So there's a scene here. Sorry, I'm gonna. Where does it show which camera it is? Don't understand. Oh, wait. Okay. I might just do this manually right now. Hold on, everyone. Where's the map? Let's just try something. I know it doesn't show you anything. I know it's a black screen right now. Okay, now how do I tell it which camera to use? No. No. No, cancel. Don't, that's not what I'm trying to do. This is what I'm trying to do. Ah, there we go. I got it, everybody. Okay, now the question is, I go here, how do I switch this one? Oh, unlock. Ah, it's locked. I see. Okay, we're almost there, everybody. Okay, now. Okay, I think I'm good. Okay. Me talking to you. Me showing what's on my laptop, talking to you. I don't know what that little interlude, and me standing in front of this whiteboard, talking and drawing on the whiteboard. And finally, the direct feed of this whiteboard where, if I'm over and actually drawing on it, oh, that's the eraser. It live animates. Fantastic. Okay. So, I'm reading some of this chat. This is an interesting question, which I will address. I know Coding Train, the comments or layout is off. Generally only covers creative coding topics, but you reckon some sort of networking topics could be covered as well. Yes! I would like to do some, I was like, this is a good question. I will answer it. And then my mind went to a blank and all that popped in was yes. So actually, I think the reason this question came up, let me bring this question onto the screen, is there's little bit of a I have some competing interests here. And what I'm really hoping to do with the Coding Train, and I'm struggling with this mentally, time management wise, technically, is once a week cover on the Coding Train the different topics that I'm doing in my actual classes at NYU. And you might be wondering, so, you know, just as we're getting started here, you might be wondering, like, what do you mean at NYU? So there is a program at NYU. It's part of Tisch. It's called ITP. That is where I work. That's my full-time job. I teach classes there. One of the current class that I'm teaching is an intro to P5 class, essentially. You know, I could say more about it, but that's ultimately what it is for total beginners learning to code with P5. And then the other class I'm teaching, which is what will form the subject of today, and this is, let me see if this, programming from, I'm just trying to memorize a URL here. There we go. Okay. So, oh, and my pinned repo is off, but here is a class that I'm teaching, and I think I'm gonna scooch this over just a wee bit here. This is a class that I'm teaching. You can read all about it in the syllabus, and one of the topics for the class is on text analysis. And many of my videos, which are on this syllabus here, you'll find about associative arrays and word counting. I did a word counting coding challenge, and I talked about this other system called TF-IDF. And I mean, I've been teaching this class for a really long time, and many years ago I made a lot of videos for it, and they're kind of out of date, but the concepts still hold true. They kind of work fine. But I never ever got to make a video on Bayesian text classification, which is kind of a quaint topic now in the age of deep learning. If that's even like, if the term deep learning is quaint, I suppose, at this point. In the age of AI, giant like echo dramatic effect. But by golly, I want to do it. So you asked about networking, but this class and other classes venture off into working on server-side programming and working with different kinds of systems and APIs, and I'm doing some machine learning stuff, and I want to do a lot of stuff with transformers.js. Too many topics. So I think what's going to happen is I teach a lot of different things every week at NYU. And I'm just going to have to pick out of the hat one thing to focus on my Monday. So every Monday I'm going to be doing this live stream. Some Mondays I might have more time to do maybe 2 parts, a morning and afternoon session, get more stuff done. I think with this cold that's coming on, that's kind of unrealistic. And I appreciate that Youssef is saying that you'd prefer if the sound was up a little louder. I've gotten that feedback. I wish there was a way I knew how to fix my settings right now. Right now I would say like just turn your volume up. Okay, so today's topic, Bayesian text classification. So at 11 o'clock, I got to just I can't have more than a half an hour of like futzing around here. I've got to be into that topic. But what I want to say is I very much want to remake my beginner P5 tutorials. That's what I'm teaching this semester. So stay tuned about that and all the stuff I said before. Okay, actually, let's get a move on here. So one of the nice things, I could make a new canvas, but I like that I can just kind of move this off to the side, which is what I'm going to do. Let's see. Let me title this, rename. Ooh. I'm just going to make the date, which is probably stupid, but 15, and then I'll do Bayes. Okay, just as a knowing what the, okay. So this is my whiteboard for Bayes. Okay. Now the other thing that I'm confused about that is an important question is, does this really make sense to do in the P5 web editor? Oh, look at me with my guest on the screen by accident. Press the wrong button. No guest today. It doesn't really, but I don't feel in the trajectory of the class, I haven't really covered node and loading text files there. Maybe I'll just do a quick demo. I'll sort of create the algorithm and make an interactive demo. And let me get this set up in a way where it will make sense. And I want to get rid of this and make sure the background is white. Okay. So, and how's this font size for people? Let me know. What is it actually? 28. I think I'm going to stick with that. Okay, so I got to just rip off the Band-Aid and start doing some of the stuff. So, okay, the other thing I'll say is I'm hoping that this live stream works as a standalone experience that somebody could watch if they want to learn about Bayesian text classification. And I should have said this right at the start. Some point later this week, hopefully later today, even as soon as later today, there'll be time codes in the video description. So if you've been watching this whole live stream archive and are like, can I just please get to the various parts that I'm interested in, go look for those time codes. Okay, somebody help Anonymous, because I can't, with this very important question. Can someone explain what's going on? New here. Not me. I can't. I don't know what's going on anymore. But welcome. And somebody will help you out in the chat. But I'm going to get started. What's going on right now is I'm about to build in P5.js a Bayesian text classification web application. And you're going to learn. The other thing, I'm having trouble here because this is what I was saying. So this standalone live stream, you should be able to watch. However, just like many, many years ago when I was a wee YouTuber who never thought I would be a YouTuber, I would live stream and then we'd sort of chop out parts and upload them separately. That's the idea. That's what's going. Well, let's see how it goes. The goal would be there will be an edited version of this coding challenge that you could watch hopefully in a 20 to 45 minute, maybe even up to an hour video that's going to cut out all of the filler and wasted time, speed through some of the sections, as well as possibly have a little bit of extra annotated overlays. But Mathieu, if you're watching or if you're looking at this later, I think the goal is like it's just got to be done by next Monday. So we're not going to do a lot of elaborate post-production. Okay. Hi, Carlos. All right, we got 200 people watching. I think that means it's time to get going. This is why I'm having trouble, though. It's like, oh, do I need to, like, how do I figure out to record an intro? Do I change at some point? I'm like, oh, I'm no longer the live streaming person babbling. I'm now the beginning of the coding challenge video person babbling. I'm going to try to do very little stopping and starting, almost none. Inevitably, something might go totally awry, if that's the right term, and I'll have to double back and repeat something. Okay. Thank you, Youssef. Okay. I'm sorry, everybody. Okay. And the other thing is, there's some lawn work, yard work going on that's kind of loud, but I think you're not hearing that. I think some of the sound filtering stuff. Did you hear that? Just a mower just went by the window. Anybody hear that? Okay. All right. So let me. There we go. Okay. Very faintly. Okay, great. Didn't hear. Okay, that's good to know. Just give me a second. I was muted. Thank you. Yes, yes, yes. Muted, muted. I'll wait for the chat to catch up. I forgot what I was saying. Somebody will have to read my lips. Don't worry. I fixed it. I fixed it. I fixed it. Got it. Got it. Got it. Okay. 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 I was just saying how I love this topic, but I don't know it that well, so we'll see what happens. All right, everybody. Hi, everybody. Welcome to a coding challenge. This coding challenge is part of my programming from A to Z class. Oh, wait. Let's have this just up on the screen. Okay. Remember I said I wasn't going to start over? Okay. All right. So many good questions. I'm gonna do some Q&A later before I leave. So save your questions till there. All right. The thing is, we got to this point where I was recording videos without doing a lot of stuff on the screen, and we were doing all that in post-production, like recapturing web pages, and I just can't do that anymore. So, but like my mind is still in that mode. So I got to pretend I have to pretend as if the only thing that could ever be shown is what's here on the screen with me. And then if we have the capability of like moving some things around if we need it, but mostly don't know. Okay. Let's just get to the good part, because I got to write that Bayes formula. Hi, everybody. I'm making a video again. And today I'm going to cover Bayesian text classification, which you might be wondering, oh boy, why? Is anyone going to watch this video? Well, you're watching it, so there. This is a topic that I'm really interested in. It's definitely a quaint topic at this point that has been superseded, swallowed, totally overtaken by so many newer transformer-based deep learning text analysis classification generation systems, and I'll make some videos about all of that. But I think it's really valuable because you're going to learn so much if you watch this video. You're going to learn about probability, you're going to learn about word counting, and you're going to learn how to make a text classifier with your own data that you can open up, look at, and totally understand how it works. Run it in P5.js right in the browser really quickly, really easily. So, I guess I'm branding this as a coding challenge video. I have a programming with text. I stopped and started. Stop stopping and starting. Just go. Just go. Just talk. You're in a classroom. When you're in a classroom and there's students there, you don't stop. Like, let me take that again, students. I have a cold. My life is so good and easy compared to I don't know what, but it feels very hard right now. Okay. And the other thing is I can just talk and we can just like take stuff out. So, all right, so this video on some level is part of my programming with text series, which hasn't been updated in over 8 years, but I think I'll brand it as a coding challenge. So it'll just sort of stand alone as Bayesian text analysis, but it is part of my programming from A to Z course which, and as part of the word counting module. So you might remember seeing a video about counting words, about TF, IDF. This is kind of the next step here. What am I saying? See, don't know. No, I'm going to keep going. Okay, let's see. That's not really important. All right. This topic really builds off of other coding challenges that I've made. The concordance coding challenge where I just count the total. Let's look at that. Let's bring these things up. Oh, I guess let's see, word counting. No, why is I really got to work on these tags. Okay. I guess I can do it this way. Oh, wait. Oh, because it's in parts. I see. Oh, look at this old thumbnail. Okay. This is from... On some level, this challenge is really, dare I say, a part 4 of my word counter in JavaScript coding challenge, where I looked at how to take a text file and count the frequency of all the words in it. We did that in JavaScript. I did it in processing. And then I also looked at this algorithm called TF-IDF, term frequency inverse document frequency, which looks at the relative frequency of any given word across a collection of documents, which might allow you to see a given word as a see, just talk. It's fine. What is Term frequency inverse document frequency is an algorithm that looks at the frequency of words across multiple documents. So, for example, if I have an article about curling, the Olympic sport of curling, and then I have an article that explains the physics of a rainbow, we're going to see the words like the and is very frequently in both of those documents, but certain other kinds of words like ice or stone might appear very frequently in the curling one, and wave or wavelength, rainbow would appear more frequently relative in the other one. It's a way of doing keyword extraction. Another kind of classic, dare I say, I mean, does it really count as machine learning? Maybe not, but it's a classic algorithm working with text that isn't a giant, 4 bazillion, trillion, trillion, bazillion parameter language model, just the thing. I don't like what I'm saying, and so I just... Okay, last time, I swear. But, it's fine, because... and then I swear I'm not. That's it. That's it for me. Choo choo, says Harp Code. Thank you. Choo choo to you too. All right, so this video really is kind of like a part 4 of my word counter series that I did. Can we find the date for this? If I click here. It was only 20 minutes and it was 8 years ago. Hey, this one only has, come on people, watch this video a little more, please. 50K is great, I'm thrilled. But you can see in this video I covered how to count the frequency of words in a document. And I also did some other parts where I looked at the relative frequency of words in a document, the relative frequency of words across multiple documents, which is a way of extracting keywords. Bayesian text classification is the logical next step. So, where is a good starting point? First, I want to tell you about Bayes' theorem. And I should say, if you really want to learn about Bayes' theorem, there are some excellent videos on YouTube. There's a 3 blue 1 brown video. Find it.
Imagine bringing your side project to life just by thinking about it. Meet Bayes 44. AI creation plan.
My side project to life.
The goal is for you to
Okay. This video is fantastic. I think there's a Veritasium video on Bayes' theorem. There's many more. I'll link a bunch in this video's description. I'm going to give you a quick chaotic overview in my own words and look at it specifically in the context of text classification. Give me a second here because the Whiteboard went to sleep. Okay. And I have... And... Muted. Ah. Wait, why did the mic get muted? I didn't press mute. How long did was it muted the whole time? Okay. I appreciate it. When I'm at the whiteboard, I can't see the chat. I love my drawing there, though. My whiteboard looks amazing. When did it start muting? Only when I went to the whiteboard? That's what I need to know. Scene transit. Oh, hold on. Let me just. Oh, because I had the mic was muted the last. Oh, I didn't realize it does that. Okay, that's fine. We're going to do this again. I actually felt I did that well, sadly. Okay. Not muted, not muted, not muted, not muted, not muted, not muted. Just checking, I'm not muted. Okay. Okay, I need to blow my nose, and I'm not going to mute the mic. Okay. Actually, I am going to mute it, but okay. I just got to make sure I'm unmuted. Still unmuted. Okay. Okay. In order to explain the Bayes theorem, I'm going to create a scenario for you. Imagine a giant library full of books. And in that library, 1% of the books are science fiction. Out of, okay. That's right. Now, in all of those science fiction books, 80% of them have the word, 80% of the sci-fi books have the word galaxy in the title. Now, I know that's probably unrealistic. A giant collection of sci-fi books won't have 80% having the word galaxy, but this is for illustration purposes. Now, why does it keep moving as I have to be careful about my body in this. Okay. Now, for non-sci-fi books, there are non-sci-fi books that have the word galaxy in the title. Non-sci-fi. 5% of them have the word galaxy in the title. So the question is for you to think about, to develop an intuition for, if I have a random book and the title has the word galaxy in it, what is the probability it is a sci-fi book? This is a question, this is a scenario that Bayes' probability theorem will calculate for us. Now, so we're going to use Bayes' theorem in a minute to calculate the exact probability number. But don't even worry about doing any math in your head. Just intuitively, what do you think the probability is? Pause, take a minute, pause the video, think about it. I'll check the chat just to make sure there's no disaster going on. Okay. Okay, you got your answer. I mean, maybe a starting point might be this is the wrong answer. Oh, 80%. But it's probably not 80% because there are also books that are non-sci-fi with galaxies, so like 80 minus 5. I mean, you could come up with all sorts of ways to calculate it or think of it, but let's look at how Bayes' theorem does this. Now, let me write Bayes' theorem. I'm actually going to move away from this for a second and just write it out for you with the original notation. Wait, where's my notes? I always forget. B or A is where. Okay. Okay, so here we go. Here is Bayes' theorem. You're over there. Bayes' theorem is over here. This whiteboard thing is really in my way. First thing is, what is even this notation? So this is standard probability notation, and once you've used it for a while, it no longer feels this way. But when you first use it, it might feel a little bit backwards to you. What this means is the probability of A given B. Actually, that's not backwards, but so I'm trying to think of a I suppose if I wanted to read it in the forwards way, I would say this is the probability of A given B. Let's come up with an example. Let's say it's sunny outside. What is the probability that means it's summer? You know, maybe it's 30%. I don't know. It could easily be winter or fall or spring, but it's like a little bit more likely than a quarter to be summer if it's sunny, because it's usually less sunny in winter. I don't know, but you get the idea. If it's sunny, what's the probability it's summer? That's what I mean by it being a little bit backwards. Okay. So in our case, what I'm saying is, what if a book title has the word galaxy in it? What is the probability that it is a sci-fi book? Okay. Let's go back to here. So now I'm going to have my other notes here, which I will just put here. So let's write this formula again, but let's use G for the word galaxy is in the title, and S for it's a sci-fi book. So what is the probability that if G is in the galaxy is in the title of the book, it's a sci-fi book? It is the probability of, if it's a sci-fi book, galaxy is in the title, times, yes, the probability that it's a sci-fi book in the first place, divided by the probability that galaxy appears in the title at all. So a couple things to note here. And I don't like, can I move something around? I don't like the way that I wrote that so close to there, but I'm going to have to keep it. Okay. I just don't like having no view into the chat, but I'm just checked it and it looks okay. Okay. We're going to get to some code, I promise. Okay, so I think it'd be worth sort of labeling some things here for a second. Let me go back to here. Where did I want to make sure I get this right. My notes here, yeah. Just heard a Discord message, which I don't, sometimes that means something's important, but come look at it. Okay. So another thing that I think is, let's just look at a couple, let's look at some terminology here. This is generally referred to as the posterior. This is the probability we're looking to calculate. And a really important piece here, one of the things that really makes the Bayes theorem tick is this concept of the prior probability. So we've got the posterior probability. That's what we are looking to calculate. We've got the prior probability, right? What are we looking for? What is the probability that the word galaxy appears in a sci-fi book title? No. What is the probability that if a book title has the word galaxy in it, it is a sci-fi book? Well, that is entirely dependent, right? We picked a random book. What's the probability? What's the prior probability that this is a sci-fi book at all? Remember, that was just 1%. That is a very, very important concept here. This is often referred to, I think, as the marginal probability. I like to think of it as like the evidence, which I think is a term that gets used. What's the probability that galaxy appears across all books is a relevant piece here. What is this called? Conditional? Likelihood? No. This would be like the condition. Everything's a conditional probability. All of these are conditional probabilities. I hate doing this where I'm imagining the edit later, and I have to like get that out of my brain. One way to get it out of my brain would just be like not have an edit later, but this is first of all, I don't know if this is really like a video that anybody will want to watch later, so it's sort of like practice. It's practice. Okay. I think this is often called the likelihood. Okay? So I wanted to just show you what is the formula, what is the terms, and now I think in order to understand the formula and how it works, it would be worth illustrating it. Okay. So let's not even do the math just yet. Let's borrow from a much better video by 3 Blue 1 Brown, and let me draw my own diagram of this library. Okay, we have this giant library. This is our library. What did I say? 1% of the books are sci-fi. So this won't be drawn precisely to scale, but let's just say this little sliver is 1% of the whole library. Now, 80% of this sliver of sci-fi books, right? These are the sci-fi books. 80% of this, let's take this and shade this area here. 80% have the word galaxy in the title, okay? 80%. Now, of the rest of the library, all of the non-sci-fi books, which is this whole extra area, all of these non-sci-fi books, right? These are all non-sci-fi. 5%, and again, I'm not going to get this exactly right, 5%. Oh, and I should use, can I undo? Dare I try a color? I can't even imagine using a color. That is the worst shading ever. But hold on. Can I do this and erase? Oh, no. Like a tiny, I wanted to, hold on. No. Undo. Let me go back. Just excited to use color here. I made this hard for Mathieu, which is the whole point not to do this, but I'm practicing. Okay. So this blue area are all of the sci-fi books that have the word galaxy in them. Do you guys hear the lawnmower going on? It's fine. It's very loud. You can keep that in. See, it's fun to keep those things in. It's so loud. Okay, now, let's keep going. This little sliver are all the sci-fi books with the word galaxy in them. Now remember, 5%, this whole area here, these are all the non-sci-fi books. And 5% of them, again, I'm not going to draw this precisely to scale, but let's say it's this much. And let's use a different color. Try red here. These are all the non-sci-fi books that also have the word galaxy in them. So we have these, everything shaded in with some color has the word galaxy. This blue area, sci-fi books with the word galaxy. Red area, sci-fi books with the word galaxy. So let's ask the question. I'm going to pick a random book with the word galaxy. Is it more likely to be a non-sci-fi book or a sci-fi book? Well, we can see, even though like only 5% of the non-sci-fi books have the word galaxy, there's so many more non-sci-fi books that's much more likely that it would come from this area. And this is the whole idea of Bayesian probability. We have this sort of like initial piece of information that 80% of sci-fi books have the word galaxy. But once we learn the prior probability and more evidence, we adjust our probability. And that's what the formula calculates for us. Let's now work out the actual math. Hold on. I guess this being here is kind of a problem. So I'm just going to erase it. So I should have started anew. Literally like cutting all the grass out here. Okay. 11:30. That's not so bad. We're going to get to we're almost through this part. Okay. So, looking at this based off the geometry, I might guess like, I don't know, what's this, like 15% of this area? I don't know. But we can actually do the math now. So I want to calculate, given the word galaxy, what's the probability that it's a sci-fi book? So the first part of this equation is, if it's a sci-fi book, what's the probability? It's so loud, the grass cutting. Okay, I have to pause for a second. We'll look at the chat. Oh, I'm losing viewers fast. I'm reading the chat here. Okay, thanks for all your, okay. I'm gonna scheduling, I'm having some scheduling trouble. Okay. It's also starting to get warm in here. See, I'm like turning beet red here. Okay. The bee is getting dangerously close to me. I had to keep going here. Okay. The probability that a sci-fi book has the word galaxy in the title, we've established, was 80%. 80% times the prior probability that any book is sci-fi at all, which is 1%. I'll wait. It's going to be done in just a minute. Okay. Now we have this new problem, which is, what is the probability that any book has the word galaxy in it? So let's just do this with intuitively, and then maybe I'll try to write out some notation for this. Okay, so we have this whole area of books. We know what I'm looking for is what is the probability that any random book, any book that I pick, has the the lawn mowing went away, and now I feel like my brain is lifted. What is the probability that any book in the entire library has the word galaxy in the title? Well, it is these are all the books divided by, these are all the books, right? The red and blue area with the word galaxy divided by the total number of books. You know what would be really helpful here, I just realized, is we should just use an actual number of books in the library. I should have done that in the first place. I can't really go back now, can I? But it's fine. Let's keep going with this. And I'm going to wrap it all up with a specific scenario. Okay, so 80% of 1% of the books have 80% of 1% of the books have the word galaxy in the title. Oh, look, we just did that. 80% times 1% plus 99% of the books, 5% of 99%. This is 5% of 99% also have the word galaxy in it. So this might be a little bit confusing. How did I go from here to there? Let's actually look at a specific scenario, and I think this will help make more sense. Okay, now let's look at this library. Let's say the library has 1,000 books in it. This means 1%, which is just 10 books. There are 10 sci-fi books, 8 with the word galaxy. Then there are how many non-sci-fi books? 990 non-sci-fi books. How many have the word galaxy in it? 5% of 990. I can't do that math. I mean, I could do 5%. I could do 5% of 1,000. That would be 50. Let's use a calculator. Oh yeah, 49.5. That kind of makes sense. Why do I have to have a half? I hate that the scenario has a half. I guess I need like 10. What if I did 4%? No, that's not going to help me. Yeah. I hate that I have a half here, 49, because it kind of ruins it. Well, the answer is 49.5 books, but you can't have a half. I should have picked a different number where I'd get a whole number, but let's just, I guess let's round that up. We're to do an approximation. Let's see. I guess I could do, I could have said 10%, and then we'd have 99. Galaxy is a very popular word in the title of these books. Does anybody have a suggestion how I can nicely resolve this question? 2,000 books. Make the total 2,000. All right, fine. I hate how the number is 49.5. So let's do 2,000 books. Which means I have 20 sci-fi books, 80% would be 16 have the word galaxy in it. And then I forgot already. 1%, so 99%. So 1,980 books then are not sci-fi books. And how many of those have the word galaxy in it? 98? 5%. Should be 98, right? $99, you dummy. I mean 99. I'm going to pause for a second to let anybody correct me if I'm wrong here. 99, okay. This means the total number of books in the library that have the word galaxy in it is 99 plus 16, or 115. So if I were to pick a book if I were to pick a random book with the word galaxy in the title, how likely is it that it's one of these blue ones, a sci-fi one? It is 16. There's 16 of them out of a total of 115. 16 out of 115 equals, I got to go to my calculator. Why do I have a different answer? Oh, no, I have the same answer. 13.9%. Boy, my handwriting is getting worse and worse over the course of this video. That is the likelihood that a random book which has the word galaxy in the title is a science fiction book. And I think you will see that this math that we did down here, which goes along with this diagram, is the same exact result of what we would get here, which is 80% times 1% is going to be 0.008 divided by 80% times 1%, which is, again, the probability, essentially, that a science fiction, the probability the probability that a science fiction book has the word galaxy in it relative to all the books, essentially. I don't know if that's a nice way to say it. I don't think I need to say anything more. We've kind of done this. Just cut that part out. I don't. Plus 99% times 5%, which is going to be, zero. Boy, this is really, really hard because it's going to be, how many zeros in the 4-9? Oh, right, 0.0495. Yeah. Did I? Oh, I put too many zeros there. I put one too many zeros here with the 8. Zero, 4, 9, 5. Yeah. Okay. And I think if we do this math out, we're going to get exactly this number. I'm pausing here for a second. I realize you probably can't see this super well. Just out of curiosity, let's put this here. This looks better. Did I have an extra, oh, the numerator? Oh yeah, why did I put an extra 0 there? 8%. No, I'm right. 80% times 1%, there's 0.008. 10% of 80% would be would be 0.08. Yeah, it's correct. It's correct. Okay. Now, why did I spend all this time fairly awkwardly trying to explain to you Bayes' theorem, its components, and looking at this example scenario? The reason why I did all of that is the following. And I'm trying to, let's use the reason is it will serve as the basis for building a simple text classification web application. I'm trying to think of, so I want to encourage you to use this algorithm and concept in more creative ways. But I think a standard way of starting with this would be sentiment analysis. I also think it's very important to emphasize that you don't just need to have two categories. Is it sci-fi or not sci-fi, for example? But so let's just think about, let's say we have this concept of sentiment analysis, and I want to be able to determine whether some text document is positive, neutral, or negative. Which one of these categories is it? What I am looking to calculate then is, and I kind of want to zoom in on this a little bit, the probability that given, okay, wait. I think I just have to keep it smaller or move to this side or underneath it. Let's do underneath it, yeah. What I'm looking to calculate then is the probability given a text that it is in any one of these categories. So let's just say that it is positive. This is equal to, guess what? All of that stuff that we did before. the probability that a positive text document, contains that text. So let's put a finer point on it. Let's say that text is, I am so happy. What is the probability that a positive document contains that text times the probability that there's a positive document in the first place divided by the probability that this text appears in any document at all. And so obviously this is a little bit different because I'm not just looking at one word, right? I could say, what's the probability that a positive text contains the word happy times the probability of the word happy existing at all, plus the probability of happy existing across all of the text in the entire known universe, or at least in my training data set. This is what we're doing. We're actually doing exactly the same thing that we did with the sci-fi and word galaxy. The difference is my category is not sci-fi or other. It's positive, neutral, and negative. My word is not a single word. My text is not a single word galaxy, but rather a collection of words. But guess what? What we're actually going to implement is something called the naive Bayes theorem. It's not the naive Bayes theorem, but what I'm actually going to implement is naive Bayes, meaning I'm going to take this sentence and chop it up into separate words. And then I'm going to say, hey, the appearance of these words are totally independent from each other. And I can use this concept of multiplying probabilities. What is the probability of two things occurring together? It's the probability of one thing times the probability of the other thing, right? What's the probability of flipping a coin heads twice in a row? It's 1 out of 4, because it's 1 out of 2 times 1 out of 2. So essentially, what I can do is I can turn these into this is hard. Picture challenge. Here's my test video stream coding challenge. What I'm going to do is look at what is the probability that the word I appears in a positive text times the probability, times the probability that M appears in that positive text times, and so on and so forth. So I'm going to multiply all these probabilities together to get that probability that a positive text contains all of these words. Times the prior probability of, hold on. Let me just look at my notes here. Yeah. Oh, yeah. Times the prior probability of positive texts divided by, and I'm gonna do something funny with this later. So let's just put a pin in that and come back to it. Okay. Any questions from the chat? Because now I'm ready to start coding. All right. Oh boy, you really can't see that when I zoom out, but that's okay because we have this. Okay. Come back to here. Okay, yes. I wish, okay, let me fix this. All right, we're ready to start coding. Dingleberry, hi Dingleberry, asks, how will you get those probabilities? Well, this is exactly what I need to figure out next. Good question. Here we go. Yeah. I almost, what would be, how would you guys feel? Like, is there some way for me to do a poll? I used to be able to do a poll. Well explained. I was kind of like, I almost want to just go redo that whole thing. Now that I kind of like went through it, I could probably re-explain the whole thing with it fresher in my mind and be a little bit more cogent about it. I'm gonna, how do I do that, the poll thing? I mean, there's a way. Okay, oh, I do it here. Is this how I do it here? Engage with your audience. Start a poll. Explain it again and see if it's better. Okay. Huh. This is fascinating to watch people vote on the poll in real time. I should be able to, I should bring it up to display it. This is like one of my white whales, Bayesian text classification. People are, I'm happy to see this, that you're all willing to kind of go with me and like listen to this again. Which you should redo the whole thing, but not now. That's not a choice. You should redo the whole thing, but just not now, please. Yes, that's not a choice. I'm very sorry, Palmyra Media. But Maki saying, "Oh God, no, not again." You could, if you don't want to see me do it again, you just go take a walk outside, get a tea, do something else. Leave this on in the background. Explain while coding. I mean, I got 39 votes, and the votes are clear. People are like, do it again. I mean, I'm gonna be explaining it while coding. I'm gonna have to, but I kind of would like a more. Honestly, like the point of this video is like, I would never have. I could never like. I don't think that I could possibly. First, I don't have the skill to do this. Plus, it's a totally different scenario because I'm doing it in real time off the top of my head. Thank you, Melissa. Melissa is who's helped me with a lot of things. I take her advice very seriously. I don't think that I could ever possibly explain it as well as like the 3 blue 1 brown video, but that's not the point. I want to have like my own like 5 to 10 minute version of it that can just get me into the code. So use 10,000 books. I think that's good. And also better to explain it from, so this was hard to understand. Let's try this again. I kind of want to, I can't stop all right, yeah, all right. You all, I'm going to let the votes go, but they're moving towards me doing this again, which I find fascinating. Now what I'm going to do is actually make a new canvas because I don't want to erase that one. And I'm going to call it Bayes 2. And Did I spell theorem right? Yes. Okay. All right. I'm sorry, I'm fascinated by your comments. So I'm just taking a minute to read them. 10,000. I think this recommendation for 10,000 books is a good idea. The thing is, the important thing here is, the important thing here is that, I'm sorry, it was, this live stream will always be available. So if somebody wants to, if there's a later video, if somebody wants to go back and watch the whole thing. Okay, I'm going to end the poll because it's pretty clear. Pretty clear result that will now be there. All right. I think I lost about 10 viewers who were like, oh gosh, I'm closing this tab. All right. I'm also sniffly. Coding part I think won't be as hard. I should not say that. Oh my God, it's noon already though. Crap. Okay, well, we're doing this. Okay. I might take a short break and come back and do the code. I have a good fair amount of time, but let's see. Let's see what happens. Okay. Hold on a sec. Okay, I'm not muted. Okay. I mean, I don't really need to do the beginning part again, but I'm going to anyway because I want to get my head into it and make it shorter because who wants to watch a long video? No, nobody these days. All right. Would code first help explain the theorem better? It might. It might. That's a good point, Michael, but let me try. Hi, everybody. Welcome to a coding challenge video. This one, I don't know. I'm going to do it anyway. This is really a part 4 of a bunch of videos that I made many years ago. Welcome to a video coding challenge where I am going to implement 8 years ago, apparently, where I looked at how to count the frequency of words. Oh, this one here. I looked at how to count the frequency of words in a document. Did it in JavaScript, did it in processing with some visualization. And then that leads to all sorts of other kinds of text analysis applications. Like you could generate the keywords for a document by looking at the frequency of words, term frequency, inversely proportional to the document frequency. So words that appear a lot in a certain document but not across the others would be highly relevant to that document. Like if I have a document, I don't keep saying document is weird, but like if I have an article about the Olympic sport of curling, it's going to have words like ice and stone in them much more frequently than any random article I might pick out of a hat. But words like and, is, or, those would be equally likely, even if they're very frequent, across many documents. So that was one example of taking word counting to the next level. The other example is applying Bayes' theorem. So I've got a really challenging task ahead of me, which is to attempt to explain Bayes' theorem to you. Now, the good news is you don't really need me to explain it to you because there are many excellent videos on YouTube. This would be, I think, probably one of the best ones, if not the best one, the 3 blue, 1 brown video on Bayes' theorem. I highly, pause this. You could go watch that and come back. I'm going to give you my own explanation. So maybe stick with me and see how I do and go watch that later. But the point of this is not for me to give you the best, most comprehensive explanation of Bayes' theorem, but look at how to apply it in the context of word counting. And the other thing, this is the syllabus page for my class, which is also relevant. I'll put all of these links in the video description. The important thing, though, that I want to say to you, however, is you might be thinking, what's wrong with you? Don't you know we have AI now and deep learning and all sorts of giant transformer models to do classification with text? Yes, and I would actually like to look at how to do that, and I want to cover things like word embeddings and text embeddings and how you can use that for classification and sentiment analysis, all that. But this is a classic algorithm. And I think it's such important foundational knowledge to these newer, fancier systems that exist today, not to mention the fact that I've got a P5, I've got the web editor here in P5. I'm going to write the entire Bayesian text classification algorithm just in a little P5.js sketch in the browser. We're going to run it. We're going to load text into it. It's going to work. I don't need a GPU or a cloud server or some pre-trained model, none of that stuff. So I think it's useful to look at this for those reasons. And, you know, maybe you agree, maybe you disagree. Let me know in the comments. I'm so happy I redid that. That was so much better. Okay. But I didn't do the hard part yet. Okay. So now I'm going to go here. How's everybody doing? I feel good. I feel good. All right. Woo. All right. So let me first just write out Bayes' theorem for you. Actually, no, I'm not going to write it out. Let's look at a scenario that's going to be relevant to text classification. Imagine a giant library. I'm going to draw it like this. And in this library, 1% of the books are sci-fi. That means 99% are not science fiction. I'm going to give you some hints along the way. I'm going to borrow from 3 Blue 1 Brown's geometric visualization with my poorly drawn diagrams. So these are all the sci-fi books. Obviously not drawn perfectly to scale, but that's maybe 1% of this big library of books. 80% of those books, the sci-fi books, have the word galaxy in the title. I got to learn how to use colors here. How do I get the black? Okay. Now, in the rest of the library, 99% of the books are not sci-fi. 5% of those non-sci-fi books have the word galaxy. So this is a scenario that we can use Bayes' theorem to calculate the answer to a given probability question, which I'm going to ask right now. Given a random book that I'm pulling from this library, what is the probability? Oh, wait. Let me start over here. With this, I got confused. Given any random book that I pull down from this library that happens to have the word galaxy in its title, what is the probability that it is sci-fi? Pause the video, think about what your answer might be. Now, there are many famous scenarios that I'm trying to think of. This is an example of a common kind of scenario that's often posed to people. Like there's, you can use, I'm trying to think of what I'm trying to say here. I don't have the references in front of my head, in front of me. Now, this is, again, this is a very common kind of probability problem. I sort of made up a weird scenario here, but there are more usual ones that people pose related to medical diagnoses or other kinds of scenarios where, ooh, shoot. That's all right. It's just this camera going off. Good thing I caught that. Now, I'm using a kind of made-up scenario here, but if you start to research Bayes' theorem and look at other stories, and now I'm just using a made-up scenario here. This camera, I think we have an issue. I think it's an overheating issue. So I'm going to leave it off for a second. Oh, coding train is never... Things were going so well, and coding train fell apart and went off the tracks. Okay. I'm going to come back over here and use this camera for a second. Check the chat. Did I say something wrong? But I don't want to draw the red region yet. Okay. What do I do about this camera? We were doing so well. I wonder if there's a setting. This is the Sony Alpha 7. I'm blowing on it to cool it down. We made it through that whole section. The problem is once it starts to shut off, the camera needs a fan. It does indeed. Do I have a fan in here somewhere? I don't think so. I have a space heater. That's the opposite of what we need. I also could just come back in like half an hour. Pause. Is there like a setting on the camera? Hold on, let's look. Find the setup, go to power setting option, change the auto power off temp setting from standard to high. Run for longer durations before shutting down. What could possibly go wrong with this? Okay, let me try this. Hold on, let me put this on the screen here so I can see it. Okay. Yeah, thanks AI overview. I'm sure it's completely accurate and nothing could possibly be wrong here. Okay. Problem is I've turned the camera on to do this, so I'm going to go to menu, setup. I'm in setup. And power setting option. Okay. Oh, I see it. I found it already. Incredible. Auto monitor off. Does not turn off. Auto power off temp. Standard high. The temperature of the device may rise to prioritize recording time. Would you like to change the setting? Okay. Okay, I've done that. Okay. All right, I'm just turning it off again. So hopefully this is going to help us. Wow, okay. Okay. All right, we're going to see how this goes. Oh, and I'm in the wrong. Okay. Now, I don't know what answer you came up with. This is a bit of a strange, like, made-up scenario that I made up. But there are many common ones if you start to research Bayes' theorem and watch some of these other videos around medical diagnoses and other types of important scenarios in life where people just have a really incorrect intuitive understanding of the probability of a given situation. Here, if you were to be way off, one reason why you might be way off, I said I was going to stop stopping and starting and just do my thing. But just give me one more chance here. I did a good job of not stopping and starting anywhere in there. And the camera temperature thing messed me up, so that's my excuse. So this is a made-up scenario. I don't know what answer you got. There are other scenarios. If you research Bayes' theorem a bit more, I'll put more information in the video description around different kinds of medical diagnoses that people's intuitive understanding of how a positive test, a diagnostic test, might really be mess up your sense of the probability that you have a given disease. No, see, I wanted to mention this, but like any way that I do it is like awkward and weird and uncomfortable. So I think I should just move on. But I'm going to move on. So what answer did you get? Now, this is a made-up scenario. If you are interested in the resources I'm providing to you on Bayes' theorem, I'm sure you could find many other psychological tests and medical tests that... Schiffman, what are you even talking about? Okay. What answer did you come up with in your head? Now, this is a made-up scenario. I'm not really trying to trick you, but Bayes' theorem really comes up often as an example of how people's understanding and intuition about probabilities can be way off. And if you research it more, in particular, you'll find about how doctors often get probabilities incorrect based on positive result on some type of diagnostic test. But I'm not going down that road. Let's stick with this. If you were to have gotten it wrong, you might overweight the fact that sci-fi books, 80% of them, which is kind of absurd. I mean, 80% of sci-fi books do not have the word galaxy in them. But if that were actually true, you might think this book has the word galaxy in it, and the probability is like really high. I don't know, 70%? But it's not. And the reason why it's not is let's keep going with my diagram here. So remember, this is the little sliver of 80% of 1% of all the books that have the word sci-fi in it in the title. Now remember, 5% of all of the non-sci-fi books also have the word galaxy in it. So again, not drawn perfectly to scale, but let's just say, whoops, whoa, oh, it selected that. I don't want to do that. Go away. Unselect it. How do I unselect it? Okay, got out of there. Again, whoa, way not drawn to scale. Undo that. I mean, if this were 1%, that would be drawn to scale. This 1% is way too wide. So I'm gonna draw the 5% also too wide. Again, not drawn to scale at all. But presumably, all of these books, 5% of all the non-sci-fi books, also have the word galaxy. So if I were to pluck a random book that has the word galaxy in the title, it's got to be one of these. It's a much smaller chance that it's a blue book than a red book. What is the exact probability? Let's calculate it. And then we're going to go back and look how the Bayes formula is actually the formula for the calculation I'm about to do. So I'm going to move some stuff to the side here. I'm going to shrink this a little bit, even though I like how big it is. Whoops. Okay. Let's say there are Let's say there are 10,000 books in the library total. 10,000 books. How many books are sci-fi? 1%. 100 books. How many of those have the word galaxy, have the word galaxy in the title? 80%. 80 books. 80 sci-fi with the word galaxy. Okay. Now, how many non-sci-fi books have the word galaxy in it? Okay, 5% of 10,000 is 500 books. No. Oh, not 10,000. So remember, we had 100 books and 80 of them, so we need 5% of... Let me do this again. $10,000 books. 1% are sci-fi. So 100 books are sci-fi. 80 of those books then have the word galaxy in them because that's 80% of 100 sci-fi books. Perfect. Now, how many non-sci-fi books are there? Well, 99% of the books are not sci-fi, so that's 9,900 non-sci-fi books. 5% of those, I wish I made it 10%. 5% of those non-sci-fi books have the word galaxy in it. So how many of those? 10% would be 990. So 445? No, 495. 495 of those have the word galaxy in it. We're going to lose our drawing for a second, but that's okay. So what that means is if I pick this random book with the word galaxy in the title, what's the chance that it's one of those 80 and not one of those 495? Well, it's 80 divided by the total number of books that have the word galaxy in them. 80 plus 495, and this equals, because I did this math earlier before I got here, this is going to equal about 13.9%. Let me just double check this with a calculator. Okay. Yep. Okay, so we worked out the scenario a little clunkily, a little awkwardly. You might want to pause, go back, do this yourself on pencil and paper. But hopefully it kind of makes sense to you. Okay, I get it. Like we figured out what's the probability that a book with the word galaxy in the title is sci-fi based on this scenario. We actually used Bayes' theorem here. I just never called it that, and I never used any mathematical notation. So this video really isn't about the mathematical notation and the theorem itself, but let's double back and see how that. Let's see how it actually is the same thing. So I'm going to just move this completely off, and I'm going to write out Bayes' theorem for you. Where are my notes? Just to make sure I get it correct. Okay. Yeah, AB. I always don't know why I can't remember that. Okay, so first of all, what is this notation? This is standard probability notation. It's a little bit confusing. What it means is, given B, what is the probability of A? So I might say like, given I just heard thunder, what's the probability it's about to rain? So B would be the event of thunder happening, and A would be the event of rain. So we're looking at this, thinking about event probabilities. So you could sort of think of it backwards, but you could also read it left to right. What's the probability of A given the existence of B? So in this case, B would be given the word galaxy being in a title of a book, what's the probability of A that it's sci-fi? And Bayes' formula is, well, it's equal to the probability of B given A times the probability of A, I think. Yes, of course, A divided by the probability of B. And this actually makes total sense because that's what we just did basically here. We did it with actual numbers of books, but it works out to say like, oh, what is the probability that a sci-fi book has the word galaxy in it? Well, that was 80%. Times, what's the probability that it's a sci-fi book in the first place? Oh, that was 1%. Divided by, oh, we have something weird now. What's the probability that galaxy appears in a title of a book at all? Well, it's the sum of all the sci-fi books with the word galaxy and all the non-sci-fi books with the word galaxy. Well, that's what we did. But we could make that a probability formula. It's the probability of a book. It's the probability that a sci-fi book has the word galaxy in it, plus the probability that a non-sci-fi book has the word galaxy in it, right? That's all of the books, the non-sci-fi and the sci-fi total. What's the probability that any of them have the word galaxy in it? I believe if you do this math out now, which was Bayes' formula, you will get also 13.9%. So a couple notes about this. The sort of key here, is that so some terminology which I think could also be useful just for the sake. So in thinking about this, there's a really key term that's essential to Bayesian probability. And it's this idea of prior probability. And that's really where people will often not have an intuitive understanding of what the prior probability is really where people get. The prior probability is really what can. The prior probability is really what people will often forget about when trying to sort of guess what the probability of a given scenario is. So in this case, like you might be thinking like, well, 80% of the sci-fi books have the word galaxy, so it's just really, really likely. But if there's such a small chance it's a sci-fi book in the first place, then it's kind of unlikely it's going to be sci-fi. There are other important terms here. This is usually referred to as the posterior. These are conditional probabilities, this syntax here. What's the probability of A given B? What else? I put in my notes here. This is sometimes referred to as the marginal probability, or I like to think of it as the evidence. And that's really kind of what and that's really what we're, I don't know if I need this part, but this is really the idea of Bayes' theorem. We are adjusting our probabilities given the existence of new evidence. Let's forget that. I think I'm good. Okay. So I'm going to move to writing the code in a second. But this is actually the core concept of, ooh, there's a B. Is it about to, are you going to see it on the camera? No, oh my God. It's flying right above me. I really wanted it to come across. There's that B. I'm just going to pause and look at the chat here. Make sure I'm not muted or anything. Okay. All right, I think this is much better for sure, because it's more succinct. Okay, so we have to remember why we're doing this. And one of the original articles that proposes Bayesian probability for text classification, although no, this is not. I don't want to say it that way. Okay. So I'm actually doing text classification here. What I'm saying is I have a book. It has a lot of words in it. How can I classify this book as sci-fi or not sci-fi? And it doesn't have to be I can do this without only having two algorithms. And actually saying sci-fi or not sci-fi is too limiting. I could say okay, I have this book, it has all these words in it. Based on the frequency of all the words in the book, what's the likelihood it's a romance novel versus a thriller versus sci-fi? this is what I want to do. And we can actually use the word counts in a bunch of existing sci-fi books and existing romance books, calculate all those word frequencies, apply them with this formula to classify new text coming in, and that's what I'm going to build into the code. I could keep going with diagramming this out. I might have to come back to it as I'm writing the code, but let's stop there. The one thing, though, that I do want to mention is that what I will actually be implementing is known as naive Bayes. And what do I mean by that? So let's say the phrase, let's say instead of just having one word, I was going to say long ago in a galaxy, right? So obviously I'm kind of getting this slightly wrong if you're thinking about the given pop culture reference that I'm thinking of. But the idea here is, right, forget about that being in a title. We're looking at all the words and the number of times they appear in a given book. What I'm trying to figure out is, given all, this is my variable txt. Well, let me fix that. Given my variable txt, given this text, what's the probability that this book is sci-fi? What I'm actually going to do is chop this up, long ago in a galaxy. I'm going to split it up into multiple words. And when I start to do things like, well, what's the probability that a sci-fi book contains the word long, I can chain multiple events together, right? If I want to know what's the likelihood I'm going to flip heads of a coin twice in a row, well, once in a row is 1 out of 2. Twice in a row is 1 out of 2 times 1 out of 2. 1 out of 4 times. And I can do the same thing. So the probability in my Bayesian formula, which I'm trying to figure out this whole block of text, which category is it? I can chop it up into words and multiply the probability of each individual word appearing in that category together. That's what I'm going to do in the code. Okay, everybody. We did it. I did the whiteboard explanation. There's so many interesting things in the chat. Astro says this isn't how you would typically do text classification. So I also just want to mention, so on my syllabus there, I would also recommend if you're looking for more background reading, A Plan for Spam by Paul Graham. You know, that's from 2001. Post describes applying everything I'm talking about to spam detection. And what's really powerful is it is not based on some universal world of what makes a spam email for anybody. It's an algorithm that can be specifically tuned to your own emails. For example, I get a lot of spam emails maybe that have the word mortgage in it. So the word mortgage appearing in an email might make my message very likely to be spam. But if I were a mortgage broker, that wouldn't be the case. So we've got to count the words and look at their probabilities of appearing for any given individual case. Okay. So it's a great article. I encourage checking it out, and some of these other videos and things. Again, I'll link to the video description. Okay. I need some data. Now I realize I have a problem. Also, good note, I think the chat is kind of reminding me, I'm just going to turn the whiteboard camera off, and I'll let it kind of cool down. Okay. I think I'm going to do... I mean, I could get ChatGPT to do this for me in 2 seconds, but I really refuse. Okay. 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 Oh, let me, yeah, this is fine. Yes, I know it's a very small amount of data. Okay, in the spirit of this being just a toy demonstration of the concept, I'm going to hard code some data here. Ideally, I would like to load much larger bits. Okay, in the spirit of me making a toy demonstration that just implements the algorithm and runs very quickly and easily in the browser, I'm going to hard code in a very, very tiny amount of data. For this really to be interesting and to work in any meaningful way, I would need to load much larger amounts of data from text files. I might even want to move this to like a server-side code to manage the loading of all that files. I'd be thrilled to come back and talk about that or demonstrate that and include some examples in that direction. But for now, I'm going to do it this way. Need some notes. Where's my other paper? I guess it's here. Right. Docs per category, work, okay. The other thing I need is a empty JavaScript object which will store all of the various counts of all the words across the different categories. Okay, so this is my empty JavaScript object that's going to have that in it. Okay. So the idea is, and now that I think of it, maybe I don't need these arrays to do this in such a hard-coded ways, but I want to say something like classifier train, and I'm going to get this sentence, I am happy, from this array of positive data, and I'm going to train my classifier Bayesian model with the category positive. And let's take out this auto refresh. It's trying to run my code, and it's not an object. I'm not making, so I also should make like a class. Maybe I will. Let's do this. Forget about having it be an object. I just like called a function. I'm like, my brain has moved 10 steps ahead. Let's put all of this into another file. We're going to do all this in setup right now. Okay. And my classifier object needs to store a bunch of things. It maybe should have a list of all the categories. I don't know. And it should have a list of all the unique words. Again, I might not use all these things. I'm just kind of literally doing this off the top of my head. And then I need to have the word frequencies. So I'm just thinking about how to do this. And the chat is saying I could use a set or a map. There are sophisticated JavaScript data structures that would be useful here, but I'm just going to use plain vanilla objects. They'll work just fine. They might not be the most efficient, but I think I'll be able to explain and show what I'm doing best that way. OK. It's going to be an object. OK, I think let's just start with this. Then I'm going to have a function called train. It gets some text in. The first thing I'm going to do is split that text up into words. I have a whole set of videos about regular expressions you could watch, but essentially I'm going to split by anything that is not a word character, letter or number. And the way that I do that is \W plus. That should split everything up. Then I'm going to say, do I just say lowercase or two lowercase? JavaScript string lowercase. Two lowercase is the name of the method I want. I'm just going to make everything lowercase to not worry about that. OK, now I'm going to go through all of these words. Oh, I'm going to need the total count. OK, I got it. I got it. Word frequencies. And I might need to rename these variables if they're not the right. No, word of words. OK. First, I need to check, is this word part of, have I counted it before? If this dot word frequencies word exists, then this dot word frequencies word dot count plus plus. This should be the count of the word across all the documents. And then I need to check if this dot word, this is OK. We need the else here. If it doesn't exist, this is fine. Let's do this. Then the count, then it's the first time. So this is my standard word counting algorithm. And again, all sorts of other ways you could write this, just trying to be verbose and simple about it. So if, and I know I've spelled frequencies wrong in a bunch of places. If I found this word before, increase its count. Otherwise, if I haven't found it before, start its count at 1. Now, if I found it before, I also need to determine if this dot word frequencies word category exists, right? If it exists for a given category, then I also need, because I need its total count across everything and its category and its count per category. Again, one could be extrapolated from the other, but let's store everything right now. And I can't seem to spell frequencies. Word frequencies, word category plus plus, increase it. Otherwise, it equals 1. And if I haven't found it before, I also not only need to start the total count, but start the count for that category. Again, redundancies, efficiencies aside, I can't wait to hear all of your comments about how to write this code better. I think this will work for my purposes. And again, I don't know that I actually need these separate lists of the unique words and the word frequencies. We'll get to that later. I love seeing this done by hand. Oh, yeah. By hand versus Python tutorials that just import NLTK. That's comment is making me very happy. Okay, now I just want to see, and I think actually forget about these arrays. Let's do this in a very silly way because and let's keep the arrays. They're bothering me up there. Okay, I'll just add some line breaks. So all right, what I'm doing now is I am just putting in some examples, and I'm going to console log the classifier, and let's take a look at what we get. Okay, what new? Oh, I forgot to add classifier. By the way, I'm using. Oh, I forgot I have this on screen here. Okay, it's fine. This could be sort of like skip to. Okay, so I'm just very briefly putting in one sentence from each of those hard-coded data sets into the train function, and then I'm going to just look at the classifier, and I need to make sure I have I add classifier.js to my index.html file, and by the way, I'm using P5 2.0. I'm not using any features of P5 2.0 in this particular demonstration, but I'm starting to put that as my version of P5 in everything I do. And stay tuned and find all the videos on my channel about P5 2.0 that may or may not exist yet. Okay. Setting count. Oh. Well. What am I missing here? Oh, okay. I see. I can't just make up a property where there's the value of word frequencies word was originally null or undefined. So what this actually needs to say is equals count. Like that's me creating this initially, and the same thing. I could just put the value in there. I see. Do I want to count or do I just want the number? You know what? I'm doing it. I don't think I need the property count. So let's actually set it equal to 1, and then there's no need for this count property. I'm just increasing it. That's what I did in the first place. Yeah. I only used .count in the top. This is now correct. I could put a whole object there with the property count equal to 1, but I'm just going to store the value 1. I might regret that later. Category is not defined. Oh, no, I do need an object because category is then an object. Okay, so this is now going to be an object with the count as 1. So count goes up, and then this could be, boy, am I doing this right? Should it be category word? I don't even know. This might all be a mistake. This is why this video is going to be 2 hours long. Now this should be fine. But maybe to be consistent, I should do this. And then I should use .count here. We do not need the canvas at all. Maybe I'll use, this is why I shouldn't be using the P5 web editor also, but it's fine. We're going to use .count everywhere. Okay? So now, just to cover this again, this probably makes your head hurt because it makes my head hurt. We're going to see the data structure that I've defined once it console logs correctly, and your head will hurt less. That also needs to be a new object. Geez, how many times can I get this wrong? Category is not defined. Yeah, the else is wrong. If this word frequencies word exists, then increase the count, check if it's a category that exists, and increase the category count, otherwise set the category count. If it hadn't existed, people are saying line 8. I don't see line 8 is just train. Oh my God. That's why you're saying line 8. This whole time, I'm passing in the text and the category. There is no category. Where do I get the category? I get the category here. Okay. Now we're getting somewhere. If the word frequencies word exists, then okay, dot count is not equal to this. Okay. Okay. This dot count should not be here. Okay, I've got it. Now we can look at this. Look at word frequencies. Every single word, like let's look at the word M. It is a total count of 2 times. In a positive text, it appeared once, and in a negative text, it appeared once. All of that work was for me to separate all of the data, the input data, into a giant list of words, know the total amount of times that word appears across all documents, as well as its individual counts for each category. Great. So let's now fix, now that that works, let's actually do this. For let data of positive data. I'm going to do it this way. Again, this is very inefficient, but we're just going to do this. Let data of positive data train positive. Data of negative data train negative, and data of neutral data train and neutral. Let's run this again and take one more look. Okay, the is in positive once, negative once, neutral twice. Awesome, by the way, is in positive once. It doesn't have a 0 for the other categories, but that's fine. We'll be able to determine it's 0 by knowing that it doesn't exist. Okay, now, the next thing I need to do is I need the results of classifier. Ooh. I don't know what this means. This error message that I just got is very bad, but I'm going to just assume everything's OK, because I don't know what else to do. OK, I see the chat, but OK. Now what I need to classify a new phrase. Just looking at these, let's make something up. Okay? So I need a function that's going to take in a new phrase and calculate that final probability of for each of the categories according to Bayes' theorem. By the way, it's almost 1 o'clock. I'm losing steam, but we're going to get through this. Just give me a minute here to turn the whiteboard back on, because I think we're going to need to come over to there. It's funny, all the ambitions I had of doing other things today. Okay. Oh, this camera's off. Let me just put this picture on the screen so we have it just in case. Okay. So, what do I need to do? Looking at this formula, I need to look at every word in the text that's coming into my function to figure out its probability. Okay, wait, hold on. So what do I need to do? I have some string. Okay, remember, I have some input text. It's got a whole bunch of different words in it. So what I need to do is look at those words one at a time and apply Bayes' rule. I need to say, like, okay, if it's a positive category, how likely is that word long to appear? Times I don't know why I didn't finish this before, the probability that the prior probability of the positive category existing at all. Not existing at all. Times the prior probability for the positive category. Okay. So we've got a new classify function. I need to chop it up into words. I also need an object called results. And what this is eventually going to contain is the final probability for each category. Oh, I'm not keeping the total words in the category. Okay, so what is the probability that a given word appear, given a category, how often does that word appear? I'll call that the word probability. Okay. Oh, I think I need, okay. I need to keep track of some other things. I need to keep track of the category counts. Let's do that separately. Okay. So if this, let's do I've got an idea. Hold on, I'm thinking through this. I need more information for my probabilities. I need to have the total number of documents. That's just, I need to know, that's gonna help me with my prior probability of what's the probability that a document is positive at all. And I need to have category counts, which is the total number of words in each category. So do I need the, no. Ugh. No, the total number of, I do need the total number of words in each category. Oh. I picked such a hard problem for today that I'm like struggling here. It's hot. I've been doing this for hours now. 10:30, 11:30, 12:30. Oh, 2.5 hours. Okay, it's not, that's reasonable. 3 hours is usually my complete limit. I haven't taken a break. I should really take a break. But let me map out what I need. This is going to help. I need to know total docs, the total amount of documents. I need to know the total docs per category. That is what I need for my prior probability here, right? I need to know what's the probability that any given document is a given category. So that's what I need. That's what I need. Okay. Now for words, I think I have what I need for words already. But I have the total number . I need the total words per category. That's what I'm missing, right? Because for the words, I actually don't need the total word count. Right, okay. This is what's going to get me this. In order to know what's the probability a given word is in a given category, I need to know its count. This is for a given word. I need to know its count per category. And then I need to know the total words. Total all words per category. This is something I'm not storing. This is what I don't have in my code yet. So I need to add that. I don't know if this makes sense to you, but bear with me. Let's go with this. So every time I call train, the total documents goes up by 1. If the category counts category exists already, then, and I'm just going to, I guess I'll do my dot count, is 1. No, increases. Otherwise, this is me just counting the frequency of the categories across the documents. Otherwise, it starts with a count of 1. Okay? So this here, this is for the prior probability. Now I'm keeping track of this. Now I have this count per category. I have the words count per category. That is right here. The words count. Okay, hold on. The words count per category. That's here. I also have the words total count, but that's not actually what I need. I need the categories total count. So this should be reversed. I'm just thinking about this. I would really like to have it category word, because then I could have category count. Okay. I'm going to rewrite this with this new way of thinking. The first thing I need to check is, does the category exist? So this is going to end up being the same code. I'm just rewriting it again. Does the category exist? If it does, the total count for that category goes up by 1. Otherwise, the total count for that category is a new counter that starts at 1. Okay? Now, once we know the category exists, I have to check if that word, I'm just doing this in the other way, has been found before in that category. Has that word been found before in that category? If so, its count goes up by 1. Otherwise, it gets a fresh start count. What have I got wrong here? What did I miss here? I can't see the syntax error. Oops. Does somebody see it? I should have taught basic P5 drawing today, clearly, but I can't stop now. I mean, is it just like my variable names are spelled wrong? No. Where's the bracket out of place? I know it's terrible, but I would happily clean it up if I could just see what I got wrong here. This is a great comment from DJ Mangus. Well, maybe somebody, the problem with this is I don't know that, why not just prepare a copy of a blank object with all the zero counts? That would work, but it requires knowing the categories in advance, which is not a good generic way to write this. But it's a very good comment. Nobody will help me. I'm going to have to help myself here. Okay. Let's run the good question. Unexpected token, classifier 48. Oh! The issue is I was doing more stuff down here that I forgot about. The syntax errors are below. So let me comment that out. There we go. My code was right all along. Okay. Let's just take a look at the classifier with the new way I'm organizing the data. Okay? So now, just looking under category counts, I have 3 positive documents, 2 negative documents, 2 neutral documents, 7 total. That's right. Word frequencies, each word, each category is the root property, and under positive, there's a total number of words in positive, and M appears once. The probability of M appearing in the positive count is 1 divided by 15, which is exactly the math I need. Now we're ready. I have the pieces. Just to reiterate, that's the math I need to know how frequently a given word appears in a given category. So both of these are the core probabilities that I need that map directly back to Bayes' formula. Oh, we are so close. Okay, Clemens says, if you ever have the word count, it will mess the count up. That's kind of a very smart comment here. I'm going to ignore that. I'm going to ignore that issue right now and come back to it later. Good point, though. Okay. All right. For every word, I need the word probability. Wait. I need to first do every category. And I have all the categories in category counts. Wait. So I actually need to get this list of positive, negative, and neutral. Those are the keys to the category counts property. This is very awkward. I'm going to show you, by the way, I've actually written a version of this that's, I think, much better. But I'm going to go with my messy style. We'll talk about how to refactor this later. Cue the refactor song. So categories equal. And although, I guess what I could do, you know what? I have a better idea. Let's put this dot categories back in. And you'll see, and then when there's a new category, I will just push it into that array. So I'm going to store my own list of all the categories, because now I first want to do for, you hear my stomach growling, for every category of categories, results index category equals some object. And now let's go over, we're going to do these. What is the right order? I'm not going to worry about the correct way to do this. I'm just going to do this a way that it will work. It will be redundant. Because now I'm going to iterate over all of the words. We need to multiply them together. So we're actually going to start with a word probability of 1. And then we're going to say the word probability equals. So what do I need? I need this dot word frequencies for this category, for this word, divided by this dot category counts no. Dot count. All right, let's do it this way. Let word count equals the number of times this word appeared in that category. Let category count equal the total number of words in that category. And the probability is, and I'm going to chain them all together, the word count divided by the category count. That is the numerator of Bayes' theorem. Actually, it's not the numerator because I also need to multiply the prior probability. But I'm going to do that at the end. I'm chaining all the word probabilities. I don't like this. Category word count. Let's call it that. So the word count, the number of times this word is in the category versus the total number of words in that category. Then, so this is P of A given B, essentially. Then I need to multiply it by my prior probability of A, which is the total category counts for that category divided by the total number of documents, which is just this dot total documents. Oh, no, whoops. Hold on a sec. Okay. Okay. Naive Bayes, I'm just putting some comments in, multiplying all the probabilities together. Okay. I just want to finish this function. Get all the words, results, look at each category, look at all the words for each category, times the prior probability. Why can I not get my brackets right? Oh, there are more brackets down there, that's why. Okay, my brackets are right. So now the results for this given category is equal to the word probability. I haven't done the denominator yet. So earlier I talked about how I'm going to do something different with this denominator, and you'll see that in a second. So I'm ignoring the denominator. But I've now calculated the numerator for a given category. So this is actually done. This is done. This is done. I chained all of the individual probabilities for a word. Oh, jeez. It's so hard to say this. This is done. Okay, this is done. Let's look at the results. Okay, let category of categories. What's wrong here? This dot categories. All right, what's the category here? Oh yeah. Okay. So I need to, there are going to be words that don't appear in a category. What if the word doesn't appear in that category? Well, I'm going to need to apply something called Laplacian smoothing. Basically, what I want to do is consider every word appearing at least once. So I'm saying here, word equals word frequencies category word dot count. I'm going to say or 1. And I got to do a little bit better than this in a bit. And actually, yeah, or 1. I'm actually going to say plus 1. There's got to be a better way to do this. I don't know why, after doing this for 10 years, I haven't learned the lesson that these like big complicated projects, it's very hard to do them live. I turn them into a video, and over hours and hours, I lose all my energy and steam. I don't know what I'm doing with my life anymore. Okay. We're going to make this work, at least. That's going to be a success for today, those of you who are sticking with me here. All right, I'm trying to think. Let me just do this for a second. Just going to put these in here for a second. Oh, but if the cat, wait, hold on. No, cannot read property of undefined. Hold on, let's just console log. What is even the category here right now? Word, comma, category. What positive? Okay. Right, there's no what here, so that's fine. But why shouldn't this work? This is also like, this is where the P5 web editor cannot handle me doing this project. Like I just need a different way to like debug. So I've also like bitten off more than I can chew here. What's undefined? Okay. So hold on. All right, I'm going to debug this properly. Don't worry, I'm going to comment all this stuff out for a second. Let's just see, does this work? Yes. Okay, so, you know, I'm getting these frequencies for every category. Because word is undefined. There's no I see. This is what's undefined. This is what's undefined. So this is why I didn't want to have the dot count property. The dot count property makes this harder. Yeah. So I'm just trying to think. I mean, I obviously could use an if statement there, but I'm trying to avoid it. I'm going to use an if statement. I'm going to show you. I wrote this code like a while ago, and I'm sure it's like much smarter than this because I did it much more thoughtfully. But I'm going to do it this method. We're going to get this working. You're watching this video. You were promised a working thing. I'm going to finish it. Okay. If this is undefined, so we're going to have a, okay, we're going to say okay, I have got it. I have the word count. So the word count is going to be assumed to be 1. And if this is defined, you're going to see this. I'm going to do some like crazy stuff here, but it's fine. What I'm going to do is say word count plus equal its actual count. I'm sure, again, there is a better way to do it. I think we can safely assume every category has words in it. So this is a form of Laplacian smoothing, which I will try to define more in a better way in a little bit. But let's bear with me. What I want to do here is basically assume like every word, the words coming in, I can't have 0 because 0 is going to break everything in all my math. So I'm going to assume, give it like the smallest amount of probability. If I haven't seen it before in this category, let's just count it once. And then I'm going to, if it actually has been seen before, I'm going to add in the actual count. And the reason why I'm adding in the actual count instead of just overriding it is I want to keep that 1. If I'm adding 1 to things that were 0, I'm going to add 1 to everything else too. Okay, so this should still work. Now the Laplacian smoothing needs another step to it, but I think this might fix all of the things that broke. Okay, better. Total documents is not defined. No problem. This dot. Okay. Now, we've got this. And when we get to the end, return results. We got to return the results. Let's go to sketch.js, console log those results. What's the other console log that's happening? I don't want to see now. Okay, here we go. Ah, look at this. I got scores. I got it 42% positive, 28% negative, 28% neutral. Wait, those don't add up to 100%. Okay, I haven't done the denominator yet. But I also haven't finished the Laplacian smoothing. I'm like 5-10 minutes away from being done in this 472-day long video that's been the longest video anyone has ever made on YouTube. My canvas went to sleep. Is my whiteboard camera still alive? Okay. Remember, I am trying to calculate, given a category, what is the probability that a word exists in that category? Hold on. I think I zoomed out too much. See this stuff a little bit thicker. Okay. That's fine. I don't know what I'm doing. Okay, whoops. Okay. Given a category, what is the probability that that word appeared in that category? It is the total word count total word count is, I don't like the way I'm explaining that. It is total count for W. It's how many times did this word appear plus 1, right? That's my smoothing, basically essentially saying like I can't have any zeros. Divided by the total count for all words. Well, if all words, if everything, if I'm adding 1 to all, if I've added 1 to the count of every word that appeared in that category, then I need to add the total number of unique words that appeared in that category to the total, right? The total count is off, plus total unique words, right? This is essentially, this line is, okay, hold on. Boy, this small eraser really makes things hard. Okay, go back to this. Okay, so what I'm doing is I'm saying I have the word happy. And I'm saying I have the happy count plus 1. And the probability happy appears in a given category is divided by the total words in that category. But if I'm assuming every word appeared in that category 1 more time than it actually did, then the total words is not correct. I have to actually also add the total unique words. Basically, I've added 1 to everything when I'm calculating the probability, so I just need to increase the total to reflect that. Now the question is, am I storing, and that's this category word count here. This category word count I need to add the total number of unique words that ever appeared in that category. I think I have that. This is the total number of, no, that's the total number of, that's not the total number of unique words, because that includes the word appearing multiple times. I should put it here. Oh. Or I could put it in here. Oh, count. I should put it here. Category counts positive unique words. I could do unique words here. So let's see here. When do I know I found a unique word? The moment I add that word to the category, I could say, where did I say I was going to add it? Category counts, count unique words. Positive category unique words. So I could say this dot category counts unique words. No, category unique words plus plus. However, if it never encountered it before, This is it here. Count one. Oh, yeah. I think the category counts already exist. They already exist up here. That's the first time I found a word for that category. I think this is right. The keys are the unique words. Shouldn't it just be words.length? So again, I could get the keys. Maybe that makes more sense. I'm just trying to keep track of everything in the data structure. But you're right. I could just iterate over the number of keys here, but there's other stuff going on, so I'm gonna keep track of it. Okay. Let's just look and see if this makes sense. Forget about the results for a second. Let's just look at the classifier. Okay. I've got 3 categories: positive, negative, neutral. For the category counts, ooh, why is this camera overheating? I've been doing this. I think this camera is now overheating. Insanity. Or did the battery die? It's plugged in. One thing I do have is extra batteries. Hold on a sec. It might be the battery. Shouldn't be because it's plugged in. But I'm going to replace the battery. Okay, this battery should be charged. Can't get this battery to go in this camera. Oh, there we go. Let's see if that fixes it. I'm guessing it was the battery, but I don't know. Okay. I need to be reminded about this. In Classifier, you're missing the line to update the probability for each word. But I can't look at that right now. Okay. For each category, I have the total number of documents and the total number of unique words. For every word, so these category counts and word frequencies do not need to be different objects, I'm realizing, because you can see, look, they have the same initial properties, and then they have count and all the words. So this could be consolidated, but I'm going to leave it separate for now. Here, I have the total number of words across the category, as well as the total number of times each word appears. Great. So I have everything I need. The only thing I need to add now is when I do this final calculation, right? Oh, I took it out. Oh, okay. This error happened again, but I'm just going to assume it's fine. I must have taken out the original word probability calculation, which now is equal to the word count divided by the category word count. Now, the category word count needs the smoothing. The word count has the smoothing by adding 1 to everything. The category word count needs the smoothing by adding the total unique words, which is where? That's in word category counts, category unique words. Category counts, category unique words. Okay? So now, I don't know what I'm doing here. I'm changing all the white space for no reason. Now we've got it. We've got the numerator, which is times equal, which is chaining together all of the probabilities of a word appearing in a given category with Laplacian smoothing. Assuming if it doesn't exist, let's give it a count of 1. Divided by the total number of words that ever appear in that category with the smoothing. Then we multiply that by the prior probability, and we have the final results, the final probabilities. Without the denominator, that's the last piece. Oh. Let's go back and look and see if the results make sense for what a fantastic and happy day. Okay, well, these numbers are kind of impossible for us to look at now because they got much smaller probably with the smoothing that I added in. Okay, I think I've fixed these already. So it's hard for me to look at these, but don't worry, the denominator is going to fix that. Let's go back to the whiteboard for the very last time and talk about the denominator. Okay. I'm going to write this formula one more time. And I'm going to look at my notes here. The probability I'm going to write this formula one last time. The probability that a given text means it is a given category. What's the probability this text is positive or neutral or negative equals the probability that that category contains that text times the prior probability of that category existing at all divided by the probability of that text existing at all. Well, guess what? I want to do this calculation for probability of neutral, probability of positive, probability of negative. For everything that we're calculating, this number and this number is going to be different depending on which category we pick. But this is just the probability of this text appearing at all across everything. And so, yes, we could calculate that. We could count up all the words in this particular text that we're looking to evaluate and divide it by the total number of words in everything we ever looked at. But this is just a constant. It's a constant for this particular piece of text that we're trying to evaluate. So you know what? We can ignore it. And instead, we can just normalize the values that we're getting out of the numerator, because that's the point. We're going to have to do that anyway. We're getting these scores, which we want to normalize to turn into 80%, 15%, 5% that add up to 100%. If this is going to be constant across all of them, we don't need to bother with it. So that was what I was thinking about all along this whole video. I was like, I'm going to get to skip that. So that's the exciting thing. So we're kind of done. All we need to do now is normalize these scores. Okay. So the very last thing we're going to do is before we return the results, I need to normalize the probabilities. So for let category of the categories, I want the probability from that category, and I want to get a sum to be 0. I'm going to sum up all those probabilities. And then guess what I'm going to do? I'm just going to divide by that sum. I'm going to do this again. Again, you could use reduce or map or whatever higher order one-line arrow function way of doing that. Can't wait to see all of your much better code doing this. But I'm just going to run through this loop again and say results category, divide by that sum, and now return the results. So this is me very quickly and easily normalizing those values. We're going to run this one more time. What did I get wrong? This dot categories. I think that's it. I really should not be using the P5 web editor for this. There we go. 85% positive, 12% negative, 2% neutral. Let's now put something on the actual web page. So I'm going to say let input, or like text input, equals create input. We'll put this in there. I'm going to do submit button equals create button. And let's put this stuff after we train the classifier. Then I'm going to have submit button dot mouse pressed and classify text. And I'm going to make another function. I'm going to do this in the most verbose, friendly, simple way. This is my event when I press the submit button. I'm going to let the text equal the text input value, and then the results is the classifier. Classify that value. Let's just console log them first. No, let's not console log them. Let's put them on the screen. And let's make all of this. This is so silly, but I'm going to make these global variables just to clean this up. Let classifier, again, there's all sorts of other ways to do this. Text input, submit button, and then results paragraph. These are all my global variables. So this is now a global variable, so I have access to it. The text input, the submit button, and now I'm going to get the value. I'm going to put the results, and then I'm going to say the results is an object. So let categories equal results. Now I'm finally using objects.keys. I refused to use this the whole way through. But objects, if I have an object with like 3 properties in it, positive, negative, neutral, I could get them into an array by doing object.keys results. And then I'm going to say the output text. The output is an empty string. And I'm going to say for let C, and I'm just going to say C of categories. I'm going to output plus equal. I need some text here. I need results, index. I need the category. Let's use a string literal. C colon, and then results of that category. And I'm going to multiply it by 100 and number format it. Look at all this. Look at all this I'm doing now. I'm going to multiply it by 100. Wait, I'm going to number format multiplying it by 100 to 2 decimal places. Who knows if what I did was right here, but this should be getting my text input, getting the results for my Bayesian classifier, getting the list of categories, iterating them, putting them into, what did I call it? It's result P, result paragraph, HTML, put that output there. Okay, ready everybody? Let's run this sketch. How do I make this longer? Oh, this is going to take me an hour. Text input, attribute width 100. I don't know. Is that right? No. Attribute. How do I do this in P5? No. Pixels? No. Somebody know how to do this? I could use a text area. Oh, this is object.keys, not objects.keys. Oh, why am I not using Copilot? I refuse to for this whole video, which makes no sense in retrospect. That's my new song that somebody will turn into a music video. Text area, fine. Create element, text area. Will this do it? But then does value still work? That's the problem. I don't even know. Okay, that worked. Okay, fine. I'm happy now. Are you happy? Submit. Oh, what went wrong? Line 47. Something's undefined. Oh, I never made it. Result P equals create P. Results here. Okay, let's try this again. I'm going to zoom in on this. Look at this interface design, people. And I know my green screen is all off. The camera got knocked because I was like changing the battery. Let me fix that. Oh, it's this thing that's like loose. Oh, that thing's loose. So it gets knocked around. Okay. What if result? Look at this interface design, people. I mean, come on. Does it get any better than that? Oh, okay. This is good. Why did my number format not work? And I forgot about, okay. So we need a line break. That's better. But number format, oh, okay. Yeah. 2, 2. Do I need 2 things? There we go. Just for the sake of art. No. It's fine. I'm just going to zoom into it. Okay. Okay, everybody. Yeah. Pretty negative, I'd say. Yep. Pretty negative, I'd say. Coding challenge complete. This might be the worst code I've ever written in a lot of ways, but I did explain it, And I did get it to work. Let's take a deep breath. I'm not going to be spending any more time in this video than I need to right now, but probably should go to github.com/Schiffman, repositories. Maybe it's not here. Oh, it's in A to Z. Should probably go to program from A to Z, repositories, Bayes classifier. This, by the way, if we look at the insights here, well, let's just leave this. Let's look at the classifier. Let's take a look at this. Okay. This is my nicer version of this. Let's just have a little walkthrough of what's in here. Okay. Word counts per category. Ah, that makes sense. You have the word, and then each category has a count associated with it. That's one way. Category, the document count, how many texts for this category, the total words across all text for this category. There we go. Total number of documents, vocabulary size. So that's something I kept as a separate property as opposed to like some kind of unique words. I just kept track of the total vocabulary size. That makes more sense. So when we get, look at this. There's an add word function. So a word probability function and a category probability function. So separating these things out into separate functions makes a lot of sense because we can have all this code to just calculate a word for a category. We can have all this code for when a new word is being added to a category. So we can check, does that word exist? If it doesn't, it's a new word, increase the vocabulary size. Initialize the count for all of those words. Initialize for the category. Then the total word count. All this stuff. Train creates, and this is better, creates this sort of empty document count, word count. You can see splits it. Oh, I'm validating the words to make sure they're actually like a word as opposed to just some string of numbers I might want to ignore. That's interesting. Word probability, it's got the smoothing. Here's some explanation of it. Look at all this. So I encourage you, if you somehow made it to the end of this video, you've seen the sort of raw struggle of a man trying to make a Bayesian text classification with only a very small breakfast and hours of time. This is a much more thoughtfully written version of it. I will also, it is my intention to turn this into a library that maybe you could use in Node.js, and I might come back and use that in a future video if there's any interest. Okay, before we go, I gotta do one more thing. I gotta put something in this particular sketch with the word count in it. Now, is this going to break it? Yes, it broke. I don't know how to fix this. I didn't have the issue. The way to fix it is to use my other code where I didn't use the count properties. I guess what we could do is name all of these this. Let's do this. We're going to do a quick one way to deal with this. Not my favorite. Find dot count. Replace with dot underscore count. Won't that work? And then this has to be underscore count. I guess I did it in other places too. I don't think there's anywhere else. I think I got it. Not a number. I miss it? Line 17. Line 17. Over the box. Thank you. Line 17, I missed it. Okay. We're back. We did it. Thank you, everybody. See you next time on the coding train. All right. Well, yeah. So, not a perfect solution, but this has got to be it. I'm done for today. It is 2 o'clock. So I'm learning some hard lessons over and over again. Honestly, I don't know if this is realistic for Mathieu to edit it together. It'll be interesting to try and see. I would like it to work, but I don't know. So this might just be it. This might be my 3.5 hour lesson on Bayesian text classification that I'll have to like time code and annotate. I mean, it was worth it to me to kind of like understand and learn it, but I don't think I made a particularly great version of it. I don't know how well this like translates into like, oh, everybody watching this is going to make like all these Bayesian text classification like experiments now. So I don't know. But you were all with me for this moment in time today, these 3 hours, and that was something. We did this together. A lot of the stuff I got to rethink and figure out what I'm going to do next Monday. I think I need to, this seemed like I think I need to get this out of my system probably, but I think that I need to focus on smaller bite-sized things that I can demonstrate, little short tutorials, and that kind of thing. All right. I was going to do some Q&A. I don't have any energy for anything. I think I'm just going to go. Going to like awkwardly, like the Homer Simpson gif, awkwardly back into the bushes. Dan, you should leave a message in this for Dan, who is making this again 8 years from now. Yeah. Stay tuned 8 years from now. Rebrand it as learning together. No, this is what a coding challenge is for me. It's the attempt of trying to figure it out on the fly. I did some preparation because I needed to like review what Bayes' theorem is in advance. But so anyway, I don't know. I appreciate your comments and your thoughts. I got to shut this off. So Mr. Muse Addict is saying, you inspired me to plug some Bayesian logic into some analysis tools I'm making for my work. So that is great. One small little incremental improvement in somebody's work somewhere in the universe is a positive thing. I learned a bit more. I have a better example that if I ever teach this again. And that's it. So I'm going to see you all. Thanks for being here for this very chaotic, long, and not perfect stream. And hopefully this cold is going to clear up and not be too tough on me. And I'll see you all next time. Next time on the coding train, next Monday. So one thing you can rely on, even though the time is a little bit, I mean, 10:30 is when I started today, 10:30 Eastern. It's probably about when it will be. But if you're trying to like organize yourself around watching the coding train, don't change your, I mean, I'm going to miss, I could very easily miss next Monday. But that's my plan, every Monday being here this semester. And we're going to sometimes do stuff like this. Mirksack said, I love this. Didn't know about analyzing text like this. There you go. I don't need to be so negative. This was good. And I'll see you all next time on the coding train. I'm going to hit the finish button. I'm going to say goodbye. Goodbye, everybody. Have a wonderful day.